Like fractions. Like fractions, have the same denominator. And to review, remember it's the numerator over the denominator. Find 5/6 plus 5/6. Using models that we've done in the past few years, and I'm using the graph paper to lay out my fraction bars. I have to add 5 of these pieces to 5 of these pieces. Okay. So 5/6 plus 5/6. And so if I put that together, I will end up getting there's 10 total pieces out of the parts that it has to be in, which is 6. So if I take those 6, I have 10 pieces. And so what does this give me? 10/6 is actually the same as 1 whole. And I notice I have 1, 2, 3, 4, 5, 6, 4 out of the 6 pieces in the other bar. But I know I can simplify and divide by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. And so my final answer, represented as a mixed number, is 1 2/3. I'm going to put a little note here. Do I need to simplify? If you ever have to ask yourself that question, or ask me that question, the answer will forever and always be yes. Let me show you where this 2/3 shows up in your fraction bar. If I broke this up into 1, 2, 3 parts, you'll notice that 2 of the 3 parts is filled in. And so that's why 4/6 is the same, or equivalent, to 2/3. You'll notice here that this is an improper fraction. Which means that the numerator is bigger than the denominator. So you have to ask yourself, how many times does 6 go into 10? 6 goes into 10 one time. I'm left over with 4 out of 10 left over, and I always keep the denominator the same, and then I simplify. In this case, subtraction is actually a little easier. I subtract the numerators, and I keep the denominator the same. So 7 minus 3 is equal to 4, and 10 stays the same, but notice I have to simplify, so that's going to divide each of these by 2 because they're both even. At least I can start with that. That's the largest factor I can see that's shared between both of them. And that gives me 2/5. 5 happens to be a prime number, so I know I can't divide any further, and so 2/5 is the answer.